Welcome back. In this section, we are trying to understand how we can use the dummy variables in seasonal analysis. Now, most of the important variables that we come across in economics are time series variables, such as the macro variables of employment, GNP, GDP, prices, and so on. Now, all of these important macroeconomic variables and time series data show or exhibit seasonal patterns, right? In the time series analysis, you might have learned this in your undergraduate courses, that in the time series data we have 4 types of components. We have the seasonal component, the cyclical component, the trend component, and an error component. So when you have a time series data with all these 4 different components of the time series present in an additive form, it is important that all these different types of components of a time series data are in an additive form. When you have something like this, you can try and de-seasonalize or remove the seasonal and cyclical component so that one can concentrate mainly on the trend part of the time series data. Now, the process of removing the seasonal component from a time series data is called seasonal adjustment or even deseasonalization. Okay, and this dummy variable technique can be used to obtain a seasonally adjusted time series. Now, how do we use the dummy variable technique? Let's understand it in terms of an example. We are talking here in this example from the book, we are talking about the sales of refrigerators, and we are trying to assess how the sales of refrigerators are moving over time in order to predict future trends. So the data is given to us in quarters. So we have quarterly data, quarter 1, quarter 2, quarter 3, and quarter 4 for every year. Okay, and we are trying to estimate whether or not there is a seasonality to these sales. You can even think in terms of demand for the standard undergraduate textbook example here is demand for ice creams or demand for umbrellas. We know that the demand for these items will typically be reflective of the season that you are going through, right? So demand for ice creams will typically always experience an increase over the summer season and decrease over the winter season. Similarly, demand for umbrellas will typically show an increase during the rainy season and a decrease during the dry weather. Here, the example that I have copied from the book talks about the sales of refrigerators, and we are trying to study the economic trend of refrigerator sales. So we are interested in deseasonalizing or seasonally adjusting the data that we have at hand, sales data, so that we can concentrate only on the trend component. The regression that will help us do that is this, where YT is the sales of refrigerators, it is in thousands. D1, D2, and D3 are the dummies which will take value 1 if the sales reported are of quarter 1, quarter 2, and quarter 3 respectively, 0 otherwise. Okay. We have a 4th dummy for quarter 4. Remember, the category that we are the variable that we are trying to represent is the quarters, and there are 4 categories: Q1, Q2, Q3, and Q4. So ideally, if you have m categories, you should introduce m minus 1 dummy variables. Here we have 4 categories and we have actually introduced 4 dummy variables. But to escape the dummy variable trap, we have omitted the intercept term. Remember, that was one way in which you can introduce m dummies for m categories. If you do that, so as to escape the dummy variable trap, you should omit the intercept term of the regression function. So here we have done that. There is no intercept term, which is why we can introduce 4 different dummies for the 4 different quarters. Now, if there is any seasonal effect in any one of these quarters, it will be indicated by a significant coefficient, statistically significant coefficient of the dummy variable for that particular quarter. So, since quarter 2 and quarter 3 generally represent the summer seasons or the hot seasons, you can probably expect alpha 2 and alpha 3 to be statistically significant, right? And if the coefficients of any of these dummies are statistically insignificant, that means that there is no seasonal component for that quarter. So, now that we have run the regression, how will you obtain the deseasonalized time series for refrigerator sales? All you have to do is find the residuals of these regressions. Okay, use your OLS technique to estimate the regression that was written in the last slide and calculate the residuals yt minus yt hat. And these residuals would represent the remaining components of the time series, that is the trend, the cyclical and the random component. Okay, so it's a very easy and very useful technique, one of the simplest ways of deseasonalizing or seasonally adjusting time series data.